Hello, everybody. My name is Alejandro, and together with my colleague Anamaria, we will be presenting our research article entitled Shallow or Deep, an empirical study on detecting vulnerabilities using deep learning. This is a collaboration between la Università della Svizzera italiana in Switzerland and la Universidad de los Andes in Colombia. It is currently noticeable that deep learning techniques are on the rise in the software engineering research community, and recently, one of its applications is related to the automatic detection of software vulnerabilities. However, in such contexts, it is worth noticing that the research community has limited empirical evidence concerning their actual effectiveness, especially when you compare them with shallow machine learning techniques. We pretend to partially fill this gap by assessing the effectiveness of deep/shallow learning techniques for detecting software vulnerabilities at function level granularity when using different models and source code abstractions. We address our goal by conducting an empirical study, starting by defining the types of classification we want to address, thus allowing us to structure our study. First, we consider binary classifiers able to discriminate between vulnerable and non-vulnerable functions. And second, we consider a more challenging scenario of classifying functions as non-vulnerable or as affected by specific vulnerabilities. Once the types of classifications are defined, we proceeded with a data collection stage, and the context of the study is represented by three datasets of C and C++ code, reporting software vulnerabilities at the function granularity level. Our first source is the dataset provided by Rozo et al., followed by the Juliet test suite available on the National Institute of Standards and Technology website. And lastly, we built a dataset by mining vulnerability fixing commits coming from events within GitHub archive. For each dataset, here you can find summarized in red the number of vulnerable functions and in green the amount of non-vulnerable functions. Overall, the three datasets account for more than 1.8 million functions. Once obtained the snippets of code, we defined abstract representation for free. Starting from the raw source code, we represented the code in five different ways in order to study how the code representation affects the performance of our models. We abstract the code and generate expressive representations based on syntactic and semantic meaning of the tokens in each function. Continuing with the approaches, my colleague Anamaria will handle the rest of the presentation.
Thank you, Alejandro. We have four different approaches. We use random forest as a representative of shallow learning. GCP AutoML, which automates hyperparameter tuning and is gaining force in the academic field. We introduce it as a novelty in our project. 2. Deep learning models, a convolutional neural network and a recurrent neural network. Once the different components of our experiments are clear, we can define our experiments. As you may remember, we have two types of classification, binary and multi-class classification. Three datasets, Russell et al. Dataset, Juliet the Suite dataset, and our own built dataset. We have 5 code representations and 4 different approaches, giving us a total of 120 experiments with the respective hyperparameter tuning. After running the experiments and analyzing the performance, we found for binary classification, the results achieved on Juliet test suite dataset can be basically omitted, having an average accuracy of 100% across all our binary experiments, We found that this is due to almost non-vulnerable samples are characterized by the presence of the static token. GCP AutoML models achieved results that are in line or lower compared to other three experimented approaches. Random Forest, our shallow model, achieved a performance comparable or even better than deep learning models. Regarding multi-class classification, Random Forest performed well across all the different multi-class experiments, being the best model for multi-class classification, showing us that shallow learning models properly tuned should be considered as a valid baseline. In conclusion, first, there is a large room for improvement in the field of automated vulnerability detection, independently from the usage of shallow or deep learning models. Second, shallow models such as the random forest can achieve competitive performance for the specific task we investigated. For finishing our presentation and as a wrap-up, I will summarize our journey. First, we present the context of our study and the motivation, followed by our main goal, which was addressed with different experiments, 120 in total, that include two types of classification, 4 approaches, and a variety of code representations and datasets, allowing us to see how accurate our deep and shallow learning models classify. Concluding then with our takeaway and contributions. If you want to explore in detail our complete process and the results of all our experiments, they can be found in our paper. A more extensive explanation is stressed in our online appendix. Thanks for watching.
Hello everyone, welcome back. So again, if you have any questions, please leave it in the paid chat. So any questions from audience? So Anne-Marie and Alejandro, while we are waiting for the questions, you did this experiment on C, C++ datasets. Do you think it would be difficult to do this experiment on other programming languages?
Okay, well, I will say we can extend our study to another programming languages. In fact, I think we are mentioning that in our future agenda. I think it will be like adversable because it depends on the lecture, right? And the programming language. So you can retrieve the tokens that you need for that specific language, and then on top of that, you can create the models that you are going to train for that specific task, namely vulnerability detection.
Okay. Awesome, thank you. Still don't have any question from audience. So I have one more for you. So you dealt with binary classification and multi-class classification, right? So by multi-class. What about multi-level vulnerabilities? Any thoughts on that?
That is one part of our future work. I think that is going to be useful to know because one part of code, a function, can have more than one vulnerability. So we can train our models to be multi-label and not only multi-class or binary classification.
Yes, okay. In fact, we were mentioning something in the paper. I think the dataset from Rozo, they are like having some data points considering multi-labeling, so namely some vulnerabilities in snippet of code.
What just happened? So Alejandro just dropped out. Okay, so seems like again technical difficulty. So thanks everyone. That's all for the session. Thank you for watching. I hope you enjoy the rest of the conference.